Hello everyone, this is Sir Brian Cordova and welcome back to another calculus lesson. So ang topic natin for today is the applications of double integral. Okay, first example ng application, the double integral is about density and mass. So mostly ang application natin ng double integrals ay more on geometry and physics. Pero magagamit din natin siya later on sa iba pang topics like statistics. So in single integrals, we have computed moments and the center of mass of a thin plate or lamina with constant density. So given yung thin plate with constant density, so meaning in every place or location nung thin plate na yon ay equal yung density. So kung gaano ka-dense yung isang point, yun din ka-dense yung iba pang point. But in double integral, we can consider a lamina with variable density. So meaning nag-iiba-iba yung sabi nating denseness noong every point. So suppose the lamina occupies a region of the xy plane, for example. So yung one point or small piece doon sa thin lamina, okay? So in unit of mass per unit area, so yung unit area na to, merong given na density function where yung rho or Greek letter rho is the continuous function on D. So siya yung tinatawag nating density function. Okay, so the density of the thin lamina at a point xy. Kung i-subdivide natin into rectangular regions, yung thin plate or lamina, so every unit area is the subrectangular region R sub ij. That means yung density function natin is the limit of the increment of mass over the increment of the area. So given the mass on every point or yung certain area, so yung increment ng area is given by the region and yung increment ng mass is given by the function. Okay? Where yung delta M and delta A are the mass and the area of a small rectangle containing point xy. So when finding the mass, it is approximately equal to double sum or the Riemann sum of the density function times the area or the delta A. Diba? Since we have the density is equal to mass over area, so yung mass would be density times the area. Where yung rho of xij, yij times delta A is the approximated mass of the region R sub ij. So the mass is equal to the limit of the Riemann sum density function times the delta area or the increment of area as k and L approaches to infinity, where yung k and L ay yung subdivisions, okay, nung ating region, which is equal to the double integral of the density function times dA, which is the area, evaluated in the region D. Next is moments and center of mass. We define moment of a particle about an axis as the product of its mass and its directed distance from the axis. So in figure, so given a direct distance from an axis of rotation, so given yung mass, so the direct distance is the perpendicular distance of the given mass away from the axis of rotation. So the mass of the subrectangular region R sub ij is approximately the product of the density function times the increment of the area. So we can approximate the moment of R sub ij with respect to the x-axis by multiplying the mass, which is approximately equal to this, times the directed distance, which is the measured distance of that mass, to the x-axis, which is the distance y. Okay, so the moment with respect to x-axis is equal to the Riemann sum of the product of the distance and the mass, which is evaluated by the product of rho, or the density function, times delta A, which is equal to double integral of y times the density function and times dA, evaluated in the region D. And for the moment with respect to y-axis, we just change kung ano man yung i-multiply nating distance. So, we have the distance or direct distance x, and so the double integral would be x density function dA. So we define the center of the mass naman, x bar y bar, so that mass times the x bar is equal to the moment with respect to y, and mass times y bar is equal to the moment with respect to x. Then the coordinates x bar y bar is the center of mass of a lamina occupying the region D and having density function rho of xy, which are given by these formulas. So since yung x bar ang hinahanap natin, so we divide both sides by m. So m sub y over m is the x bar. So m sub y naman is the double integral of x density function dA. So yung 1 over m is multiplied. Same with y bar. We have moment with respect to x over the mass, which is equal to 1 over m, which is mass, times the double integral of y density function dA. So where the mass is m, it is given by the double integral of the density function dA evaluated in the region D. Example, find the mass and center of mass of a triangular lamina with vertices 0, 0, 1, 0, and 0, 2 if the density function is rho of xy is equal to 1 plus 3x plus y. So let's graph the triangular lamina. So the coordinates are the origin 0, 0, 1, 0, and 0, 2. So that is the triangular lamina. So solution is that take note natin that yung upper boundary is a linear function, y is equal to negative 2x plus 2, which can be changed into 2 minus 2x para walang negative sa unahan. So yan yung ating boundary on the upper side. So the mass can be solved by getting the double integral of the density function times dA over the region D. So it is the double integral of 1 minus 3x plus y, so that this is the density function, times dA is dy dx. So yung y ay evaluated from 0 to y is equal to 2 minus 2x, and x is evaluated from 0 to 1. Then performing the inner integral, so we have 1 is y, so 3x we have 3xy, then plus y we have y squared over 2, then y is from 0 to y is equal to 2 minus 2x dx. Then substituting, we have 2 minus 2x plus 6x minus 6x squared plus 2 minus 4x plus 2x squared. Then simplifying that, we have a factor of 4 and the remaining function 1 minus x squared dx. So performing the last integral, so 1 is x minus x squared magiging x cubed over 3. evaluated from 0 to 1. So substitute the values of x. We have 4 times 1 minus 1/3, which is equal to 8 over 3. So 8 over 3, yun yung mass natin. So to find the center of mass naman, x bar is 1 over m, double integral of x times the density function dA. So substituting all values. So mass is 8 over 3, so we have the reciprocal 1 over m, 3 over 8. Then x multiplied by the density function, we have x plus 3x squared plus xy. Then dA is dy dx, evaluated from 0 to 2 minus 2x for y, and for x we have 0 to 1. Then performing the inner integral, we have xy plus 3x squared plus y plus x y squared over 2. Y is from 0 to 2 minus 2x. Okay, then substituting and simplifying, we have 3 halves and x minus x cubed. Then performing the last integral, we have x squared over 2 minus x to the fourth over 4, evaluated from 0 to 1 multiplied by the constant multiple 3 over 2. So we have 3 over 2 times 1 half minus 1/4, which is equal to 3 over 8. So 3 over 8 is the x-coordinate of the center of mass. For y-coordinate, we have 1 over m double integral of y, density function dA. So substituting all values, same process with the x bar. So let's get the double integral, performing the operations and evaluating the limits, substituting the values of y and values of x, and simplifying the resulting answer, we have 11 over 16. So the coordinate of the center of mass of the triangular lamina with mass of 8 over 3 is 3 over 8, 11 over 16. Another example, number 2. The density of any point on a semicircular lamina is proportional to the distance from the center of the circle. Find the center of mass of the lamina. So ang lamina natin is a semicircular lamina. So given a radius A, so unknown radius. So sabi lang dito at any point. So proportional dun sa distance from the center with distance A away from the center. Find the center of the mass of the lamina. So solution, the distance from a point xy to the center of the circle is equal to the direct distance, which is square root of x squared plus y squared. So distance formula, center at origin. So the equation of the circle is x squared plus y squared is equal to a squared, where a is the distance away from the center of any point. So the density function is equal to a square root of x squared plus y squared, where k is some constant. Okay? So yung ating square root of x squared plus y squared is equal to r. Pwede nating i-change yung coordinates natin into a polar coordinate since ito ay circular. Now, the region would be defined on r theta, where yung radius natin is from 0 to a, and the central angle is from 0 to pi since semicircle siya. We have 180 degrees. And the mass is solved by getting the double integral of the density function times dA on this region. Since the density function is k square root of x squared plus y squared, so substitute, get the double integral of this expression. We have kr, we have the density function is equal to k, then square root of x squared plus y squared is equal to r, so we have kr. Then dA, and the polar coordinate, we have r dr d theta, where yung r is from 0 to a and the theta is from 0 to pi. arranging the integrals with their respective variables. So, d theta is for 0 to pi lang. So, yung r squared dr is for 0 to alpha, 0 to a. And k is a constant. Evaluating both integrals, we have k pi r cubed over 3. Evaluated yung r from 0 to a. We have the mass is equal to k pi a cubed over 3. Given that mass is equal to k pi a cubed over 3, since both lamina and the density function is symmetric with respect to the y-axis, then the x bar is equal to 0. So, balance. Symmetric siya sa y-axis. So, ang x-coordinate niya would be 0. Ang solve na lang natin is the y bar or y coordinate ng center of the mass. So we have y bar is equal to 1 over the mass times the double integral of y density function dA. Okay? And substituting the values, we have the reciprocal of the mass is 3 over k pi a cubed and double integral of r sine theta, which is equal to y, the polar coordinates. Then density function kr, and dA is r dr d theta. Then r is 0 to a, and theta is from 0 to pi. Arranging the variables, we have the constant that we have cancelled k dito since constant sila. We have the remaining constant 3 over pi a cube integral of sine theta d theta from 0 to pi times the integral of r cubed dr from 0 to a. Then evaluating the limit, integral of sine theta is negative cosine theta from 0 to pi, then r cubed is r to the fourth over 4 from 0 to a. Substituting the values of x and y, we have constant times 2a to the fourth over 4. Then combining, we have 3a over 2 pi. That is the y coordinate, meaning the coordinate of the center of the mass is 0, 3a over 2 pi. Another application is for the moment of inertia, so mostly physics. It is also called the second moment of a particle about an axis. So the inertia is equal to the mass times the direct distance squared. So yung direct distance natin is the radius itself from a center or an axis. So r ang ginagamit. So the moment of inertia about the x-axis is I sub x is equal to the double integral of y squared, since yung radius natin or the direct distance is r squared. So ang direct distance natin about the x-axis is y. So we have y squared times the mass is the density function times the area, which is derivative of a. And moment of inertia about the y-axis is, papalitan lang natin yung variables. We have I sub y is equal to double integral of x squared density function dA. Then moment of inertia about the origin, or the what we call the polar moment of inertia, is I sub 0, or the origin, is equal to double integral of x squared plus y squared, which is equal to r squared, or yung distance from the origin, then density function dA, where it is equal to the sum of the moment of inertia about the axis. Example, find the moments of inertia I sub x, I sub y, and I sub 0 for a homogeneous disk with density function equal to rho itself, center at the origin, and the radius a. So the region is x squared plus y squared is equal to a squared. Then transformed into a polar region, we have r theta, where r is from 0 to a and the theta is from 0 to 2 pi. Then I sub 0 is the double integral of x squared plus y squared dA. It is equal to rho, which is the density function, r squared r dr d theta, since yung x squared plus y squared is equal to r squared, r is from 0 to a and theta is from 0 to 2 pi. Rearranging the integrals, we have rho integral of d theta from 0 to pi, integral of r cubed dr from 0 to a. And performing the integrals, we have 2 pi rho times r to the fourth over 4, where the values of r is from 0 to a, substituting values of a, other values. Substituting the values of r, we have pi rho a to the 4 over 2, okay, since we have 2 over 4. Since I sub 0 is equal to I sub x plus I sub y, and the is symmetric to the origin, kung symmetric siya sa origin, since homogeneous disk siya, circle, so yung moment of inertia about x and y are equal. Since they are equal, we have I sub 0 is equal to I sub x plus another I sub x, which is they are equal, we have 2I sub x. Then I sub x is equal to I sub 0 over 2, and it is equal to pi rho a to the fourth over, since yung mass is equal to the density times the area, density rho times area of a circle is pi a squared. So, etong moment of inertia at the origin can be changed into 1/2 rho pi a squared times a squared. So, etong gitna would be equal to the mass. So, we have 1/2 m a squared, which is one of the equations or formula for finding moment of inertia about the origin or center of the circle. So I sub 0 is 1/2 m a squared. Thus, if we increase the mass or radius of the disk proportionally, we increase the moment of inertia. In general, the moment of inertia plays much the same role in rotational motion that mass plays in linear motion. So yung moment of inertia is for rotational motion, and yung mass is mas nakaka-influence sa linear motion. So the moment of inertia of a wheel is what makes it difficult to start or stop the rotation of the wheel. So just as the mass of the car is what makes it difficult to start and stop the motion of the car. So sa linear motion, ang nakaka-influence ay yung mass ng car or mass ng object. So rotational motion naman is the moment of inertia of the object. So as an example, so ito yung mga example objects. We have red is spherical shell. So walang laman sa gitna. Yung orange is spherical solid. So solidong-solido just like a marble. Yung green is a hollow cylinder. So this one. Then yung blue is a solid cylinder. Okay. So nakikita natin is yung different acceleration nila or motion. So nakakaapekto yung bigat ng object or yung mass. Okay? Ang mas mabilis gumalaw is yung solid, like the spherical solid and solid cylinder, because of its mass. So mas nahihila agad siya ng gravity. And doon naman sa by shape naman, the moment of inertia is different between cylinder and a solid. So one application is about probability. The probability density function of a continuous random variable. So this is statistics probability. The f of x is greater than or equal to 0 for all variables x. So the integral of the density function fx dx evaluated from the negative infinity up to positive infinity is equal to 1. So the probability of the random variable in a given interval a to b is equal to the integral of the density function dx evaluated from that limits. So The joint density function of x and y is the function f of two variables such that the probability that x and y lies in a region D. So since ito ay single integral, single variable lang, so the joint density function, we have two variables, which now is just like a function of xy. So the probability of the joint function xy that lies in region D is equal to the double integral of the density function fxy dA evaluated in the region D. In particular, if the region is a rectangle, so yung x natin is from A to B and yung y is C to D, it is the double integral of f of xy dy dx, where y is from C to D and x is A to B. So the density function is greater than or equal to 0, and the double integral of the density function is evaluated in R2, which is the total probability is always equal to 1. So in geometrical illustration, itong itsura niya. If the region is rectangle, so we have A to B in variable x, C to D in y, and the function is the z coordinate. Example, if the joint density function of x and y is given by the function f of xy, where it is equal to c times x plus 2y, if x is from 0 to 10 and y is from 0 to 10 also, and if the function is equal to 0 otherwise, find the value of c, then find the probability that variable x is less than or equal to 7 and y is greater than or equal to 2. Solution: finding c by ensuring that double integral of the density function dA in r squared is equal to 1. So paano yun? So let's evaluate the double integral of the density function by substituting the density function c times x plus 2y evaluated from 0 to 10 on both x and y. Okay, then in performing the inner integral, we have 10x plus 100. And performing the outer integral, we will have a answer of 1500. Now this should be equal to 1 since we ensure that the total probability is equal to 1. So C is equal to 1 over 1500. So the probability that x is less than or equal to 7 and y is greater than or equal to 2 is evaluated by the double integral of the density function dy dx, where your y is from 2 to positive infinity, since y is greater than or equal to 2, so its limit is from 2 up to positive infinity, and x is below 7, so we have negative infinity up to 7 only. So substituting the density function and the value of c, so we have double integral of 1 over 1500, which is equal to c, times x plus 2y dy dx, where y is from 2 to 10, since our limit previously is from 0 to 10 only, and your x is from 0 to 7. So evaluating the integrals, okay, so we will come up to an answer of 868 over 1500, or approximately 0.5787. This is the joint probability of x and y. Another example, by independent random variables naman, the manager of a movie theater determines that the average time moviegoers will wait in line to buy a ticket for this week's film is 10 minutes, and the average time they wait to buy popcorn is 5 minutes. Assuming that the waiting times are independent, find the probability that a moviegoer waits a total of less than 20 minutes before taking his or her seat. So, ang solution natin, we have to create a model of waiting times by using exponential density functions. So, ang density function natin would be f of t. So, since it is a function of time, so gagamitin natin is the exponential density function where the density function is equal to mu raised to negative 1 times e raised to negative t over mu if t is positive or equal to 0. And the density function is equal to 0 if t is less than 0. So, since time ang sinusukat natin, wala tayong negative time. So, 0 yung negative. So, assuming that both the waiting time, the variable x, for the ticket purchase and the waiting time, the variable y, in the refreshment line is equal to f sub 1 of x is equal to 0 if negative yung x, 1 over 10 times e raised to negative x over 10 if positive yung x, and f sub 2 sub y is equal to 1 over 5 e raised to negative y over 5 if y is positive or 0. Since yung mu natin is actually the mean and t is the variable. Okay, so we have the x and y variables. So we just substitute the values of the average waiting times. So we have 10 minutes for variable x, which is the waiting time to buy a ticket, and to buy popcorn we have 5 minutes. Now, since x and y are independent, their joint density function is equal to the product of each densities, f sub 1 of x times f sub 2 of y. So this is the density function. It is equal to the average time of 1 over 50 times e raised to negative x over 10 times e raised to negative y over 5 if x and y are positive or 0. And its value is 0 otherwise. So the probability that x plus y is less than 20, so ang tinatanong is less than 20 minutes yung paghihintay. So anong probability that yung paghihintay ng any moviegoers would be less than 20 minutes is equal to the probability that the joint density function is inside the region. Yung region natin would be, so the limit of the sum of the waiting time would be 20 minutes. So we have x plus y, the variables x plus y is equal to 20. So it is a linear function. So ito yung boundary natin for the region. So the double integral of the density function f of xy dA over the region D is equal to the density function 1 over 50 e raised to negative x over 10 times e raised to negative y over 5 dy dx, and yung y natin is evaluated from 0 to the linear function y is equal to 20 minus x, and yung x natin is evaluated from 0 to 20. So performing the inner integrals, okay, so simplifying that, we have this one. So ingat lang sa pag-evaluate ng exponential functions. Okay, then simplifying this one, we have this expression. Then evaluating the last outer integral, we have this one, which is approximately equal to 0.7476. So the probability na ang waiting time na nako-consume ng kahit sinong moviegoer, mako-consume niya is less than 20 minutes is just a probability of 0.7476. Another application of an example for probability, the normal distribution. Example, a factory produces a cylindrical shaped roller bearings that are solved as having diameter of 4 centimeters and length of 6 centimeters. In fact, the diameter variable x are normally distributed with mean 4.0 centimeter and standard deviation of 0.01 centimeter, while the lengths, the variable y, are normally distributed with mean 6 centimeters and standard deviation of 0.01 centimeter. Assuming that x and y are independent, so independent variables din sila, write the joint density function and find the probability that a bearing randomly chosen and find the probability that a bearing randomly chosen from the production line has either length or diameter that differs from the mean by more than 0.02 centimeters. So ang solution, given that x and y are normally distributed, so we have a average mean sub 1 is equal to 4 centimeters para doon sa diameter and mean sub 2 is 6 centimeters para doon sa lengths. And the standard deviation of both 0.01 centimeters. So the density function is given by the normal distribution formula. Okay. So the individual density function for x and y are f sub 1 of x ay substitute lang natin yung kanyang standard deviation and the mean. For f sub 2 of y, which is for the lengths, we have this one. Since x and y are independent, then the joint density function is the product of their densities. So kapag kinuha natin yung product, we have this one. Okay? So simplifying that, we have 5,000 over pi e raised to negative 5,000 times x minus 4 squared plus y minus 6 quantity squared. And since mu sub 1 is equal to 4 and mu sub 2 is 6, and yung nahanap is magkaroon ng defect or deviation na 0.02 centimeter. So the probability that x is so that the probability that the diameter x is from 3.98, so may difference na 0.02 up to 4.02, and yung kanyang length is with difference of 0.02, 5.98 hanggang 6.02. So it is evaluated by the double integral of the density function f of xy dy dx evaluated from their limits. So y is from 5.98 up to 6.02 and x is 3.98 hanggang 4.02. So performing the integrals, substituting the values, which is approximately 0.91. So since ang hinahanap natin is the difference more than 0.02 centimeter, so kukunin natin is yung 1 minus this one. So we have 0.91. 1 minus 0.91, we have the probability that mas malaki yung diameter and length niya by 0.02 centimeter. We have a probability of 0.09 or just 9% probability. So our next discussion would be about triple integrals. So thank you for listening and watching. So see you in next lesson.